If you saw the GSD versus OpenSpec comparison I did recently, this video will look familiar in shape. Lean tool versus heavier tool. The heavier tool produces slightly more rigorous output, and the leaner one gets there faster. I will not pretend that this is a brand new finding. What I want to figure out in this video is where Spec Kit actually sits on that spectrum, because Spec Kit is not GSD, and the differences matter. I gave the same brief to OpenSpec and Spec Kit on 2 consecutive days. The brief is the dog food PRD I built for this kind of testing, a self-improving Python coding agent with 9 features and 9 acceptance tests. Both runs went through Claude Opus 4.7 on the 1 million context tier in Claude Code. I set reasoning effort to low so the test fits into a 1-day filming window. Without that, Spec Kit alone would have taken much longer. OpenSpec shipped a working agent in about 2.5 hours of wall clock, including some video recording overhead, not just the framework, for $30.26 on Claude. Spec Kit took roughly 5 hours and $54.83. Both passed 9 out of 9 acceptance tests. A note on audience attention as of today, May 11, 2026. OpenSpec sits at 47,000 GitHub stars. Spec Kit sits at nearly 96,000. Spec Kit has roughly double the public mindshare. This is the rigorous follow-up to a comparison I did about half a year ago. I measured wall clock, parsed tokens through CC usage, applied formal cat score scoring, and pushed both repos publicly. Not picking a winner. Placing Spec Kit on the spectrum between OpenSpec on the lean side and GSD-with-auto-mode on the heavy side. Before getting into the runs, here's a quick refresher on how these frameworks expect you to work and what each has shipped since I last looked. If you did not catch the previous comparison, I'm going to cover OpenSpec briefly here too, so you do not have to hop back and forth. OpenSpec is the smaller of the two in scope. The core loop is propose, apply, archive. The commands are opsx propose, opsx apply, and opsx archive, since v1 rewrite. Propose creates a change folder with a proposal, a design doc, a task list, and delta specs. Apply works through the task list. Archive merges the delta specs back into the canonical spec. It prompts you to run sync during archiving, though sync is a separate step, and on the default core profile you may need to install it first. There is a validate step outside the core profile that runs a sanity check on a proposal, worth keeping on for peace of mind even if it mostly finds nothing in a healthy run. Since I last looked, the new work in OpenSpec is mostly polish and stability fixes. Version 1.3.1 shipped about 3 weeks ago. It is a list of small fixes. Better path handling, hidden requirement detection inside fence code blocks, cleaner JSON output and silent telemetry on firewalled networks. After that patch, KimiCLI was added as a supported tool, skills only for now. The bigger thing is workspaces. Most of the recent commits are workspace foundation work. It is not yet open to the public, and from the outside it is not totally clear how the workflow is going to look. The signal is that this is the next big shipping target. Spec Kit runs a heavier loop. You start with Spec Kit constitution, which writes a set of named principles the framework treats as binding rules across the project. Each epic then goes through a 5-step cycle: specify, plan, tasks, analyze, implement. Spec Kit also creates a feature branch per epic automatically. What is new in Spec Kit is the opposite story. 13 releases in 4 weeks, around 160 commits. The constitution now loads during implement, not only during plan. So the governance principles are active during the coding step, not only during planning. There is a specify self-check and self-upgrade command pair, so no more pipx update rituals. The most interesting Spec Kit change is the plugin and extension system. The catalog has over 80 community extensions plus a growing set of presets, and there is now a discovery CLI for browsing them without leaving the terminal. Presets can stack, prepend, append or wrap templates and commands, so multiple presets layer cleanly. The one extension worth naming for this video is TinySpec, a lightweight single-file workflow that lets you skip the heavy multi-step loop on small tasks. It is the lightweight path that CoreSpec Kit does not have, and it is a third-party plugin rather than a built-in command. I have not run TinySpec myself, so I will not pretend to review it. The point is that SpecKit's identity is extensibility in a way OpenSpec's identity is not. The contrast is real. OpenSpec is in slow, deep build mode, putting most of its energy into one big feature that has not shipped yet. SpecKit is in feature blitz mode, pushing meaningful changes weekly through a new plugin architecture. Two different bets on how an SDD framework should evolve, and the release history makes those bets visible. Before getting into the actual runs, if you like this kind of measured comparison with actual walk log, parse tokens, and both repo pushed publicly, subscribe to the channel. I'm trying to make this useful instead of rephrasing what each tool's website already says. And if you want to talk to me or other people who care about this stuff, join the Discord. It is still small, and small means you can actually have a conversation in there. The link is in the description below. Before invoking OpenSpec, I split the PRD into 5 phases with a plain Claude prompt and saved them to a phases.md file. OpenSpec does not have a high-level command that splits a PRD for you, so this is the small piece of rework you do outside the framework. Phase 1 was foundation work. Project setup, dependencies, the LLM client interface, the .env scaffolding, and the smoke test against the real moonshot endpoint. The apply took about 2.5 minutes. One test failed when a real API token was present, and the verify step fixed it in line before moving on. Phase 2 was the solve loop, the sandbox, and the circuit breaker. Apply ran in about 5 minutes. 27 tasks all came back green. 35 tests passed, and Verify only found a small path naming issue. Phase 3 added persistence and the structured reflection prompt. Apply ran in about 5 minutes and 40 seconds. Findings were minor. A redundant local variable was the worst thing Verify could find. The interesting part of Phase 3 was trying to actually demo the self-improvement history. KimiCape 2.6 turned out to be too smart for the test scenarios I had prepared. Starting in Phase 2. Every task I threw at it succeeded on the first iteration. By Phase 3 I had to write a separate first failure demo.py with deliberately tight sandbox limits. That forced a sandbox timeout, triggered the reflection step, and let me see iteration 2 for real. That is a real-world testability quirk, not a framework problem. It is the kind of thing you only find out when you actually run it. Phase 4 was the cross-run memory layer. Apply ran in about 5.5 minutes. This is the design choice I want you to notice for later. OpenSpec went with TF-IDF similarity over JSON-L stores in a memory directory under the home folder. There is no vector database in the loop, and retrieval does not call out to a provider. It runs offline against tokenized text. That avoids a whole class of problems that, as you will see, SpecKit runs into directly. Phase 5 was the memory inspector CLI. Apply ran in about 2.5 minutes. 18 out of 18 tasks landed, 7 out of 7 requirements covered. Real wall time on the whole run was about 2.5 hours. A good portion of that was video recording overhead, not OpenSpec itself. Peak context fill on the 1 million tier was around 9%. Never strained. At the end I asked Claude to verify the entire app against the PRD at max effort. The codebase ended with 96 unit tests. The final external verification pass ran 81 of them and came back clean. All 9 PRD acceptance criteria passed too. The only flaws were cosmetic. A label swap between T4 and T5 relative to the PRD, and a small phrasing issue in the README. The framework stayed out of the way, and the loops stayed short enough that I never felt trapped in the workflow. The SpecKit run started with a slightly heavier setup. I installed Specify through UV tool and got version 0.8.7.dev, the latest pre-release on PyPy at the time. The latest tagged stable was 0.8.6. SpecKit installed itself as a set of native skills under the .claude folder, which felt smoother than I expected. Same as with OpenSpec, I split the PRD into 6 epics with a plain Claude prompt first, and saved them outside the framework. Neither tool has a high-level PRD split command yet. The first thing you run inside SpecKit is SpecKit constitution. I wrote 5 principles: single provider discipline, sandbox safety, acceptance test back delivery, inspectable memory, and framework neutral PRD fidelity. These are not decoration. From version 0.8.6 onward, the constitution loads during SpecKit implement as well as during SpecKit plan, so the principles are active during the coding step, not only during planning. Then, for each of the 6 epics, I ran the loop. Specify took about 2 minutes, plan took 3 to 6, tasks took 2 to 3, implement took 6 to 9. Analyze ran before each implement, but I did not track its time separately. SpecKit also creates a feature branch per epic on its own, 001 Foundation LLM client, then 002 and so on. This is genuinely useful and different from OpenSpec, which stays on main throughout. The Analyze step earned its place. Unlike OpenSpec's Validate, which mostly found nothing this time, SpecKit Analyzed consistently surfaced real issues before implement ran. That is the single best polish helper I have used in either framework. The hard moment came in Epic 5, the persistent memory epic. SpecKit's design wanted moonshot embeddings. Moonshot does not expose an embeddings endpoint. The code degrades gracefully. Records persist with an embedding status missing field and nothing crashes. But actual semantic retrieval cannot work without switching to a different provider. This is the design split I flagged in the OpenSpec section. OpenSpec went with df-idf and avoided the entire class of problem. SpecKit's choice is more ambitious and produces better retrieval when the provider supports it. On this provider, in this run, the memory feature ended up with a real practical caveat. There was also a small moment in the pricing work that I want to mention separately. Claude was inventing moonshot prices when filling out the cost tracking module. I noticed the numbers looked suspiciously round and challenged Claude on them. Claude then went and looked up the actual documentation and updated the values. The point is not that Claude is bad at this. The point is that even a strong model will invent quantitative answers if you let it, especially around money, math, and data. Verify the numbers. Real wall clock on the SpecKit run was about double the OpenSpec run. The framework took the time it needed and produced more written artifacts in exchange. The tone was deliberate. Not slow in a frustrating way, just deliberate. That said, by the 3rd or 4th epic I caught myself missing GSD's auto mode. SpecKit makes you type each command in per epic loop manually, and there is no built-in way to chain them. That is the difference I want you to keep in mind. SpecKit feels like GSD without the autonomous chaining. Only the planning depth remains. Headline numbers first. OpenSpec finished in about 2.5 hours of wall clock. SpecKit took roughly 5, about double. On Claude Opus, OpenSpec cost $30.26. SpecKit cost $54.83. That is plus 81% on SpecKit for the same delivered PRD. Total tokens through CC usage came out to 35.4 million on OpenSpec and 59.8 million on SpecKit, about 69% more. Code volume goes the same way. OpenSpec landed at around 1,844 lines with 96 unit tests. SpecKit at around 2,751 lines and 189 unit tests. When I scored both frameworks against the CAT score rubric, the composite numbers landed at around 7.5 out of 10 for OpenSpec and 8.0 for SpecKit. OpenSpec's raw average was actually 7.75, sitting right on the rounding boundary, and I rounded half down. The interesting part is the profile underneath. SpecKit scored higher on spec quality, plan quality, implementation quality, and verification discipline. OpenSpec scored higher on first result, polish cost, and developer experience. SpecKit wins in rigor, OpenSpec wins on day-to-day ergonomics. The same half-cat composite gap as the GSD comparison, but the roles are reversed. OpenSpec won that one. On the engineering substance, the two implementations put their care in different places. SpecKit's sandbox is genuinely harder to escape. It snapshots m times around the iteration directory and resolves symlinks explicitly to detect escaped attempts rather than following them. It scrubs the environment so generated code cannot reach the parent's home folder or the API key. It caps std out at 262 kilobytes so a runaway test cannot balloon memory. OpenSpec's sandbox checks paths with path.relative2 and trusts the rest. OpenSpec wins on the data layer. Atomic TMP plus fsync plus rename writes and a schema version field stamped on every record mean the day you need to migrate the JSON-L format you have a path. SpecKit appends to JSON-L with no version field. Both pass the same 9 acceptance test and neither has automatic retries on transient LLM errors. That is the biggest shared weakness. The surprise for me, looking back at both runs, is how similar these frameworks feel now. 6 months ago, I would have told you SpecKit was visibly heavier and OpenSpec was the lean alternative. Today, the gap is narrower in both directions. OpenSpec stayed lean and got more capable. SpecKit used the extra hours to produce a slightly more rigorous codebase. The extra planning minutes do pay off, but the gap in delivered quality is smaller than the gap in elapsed time. The implementer, Claude Opus 4.7, carries a lot of weight either way, and you can feel that in how close the final products end up. So where does this leave you if you are choosing between these two today? OpenSpec remains the framework I would reach for first on most projects. The loop is short enough to keep me engaged with the work, and the data layer engineering quietly pays off later. Atomic writes and schema version field on every record are the kind of thing you do not notice until you need to migrate the format. For a solo developer or a small team on a greenfield project, this is the obvious pick. SpecKit is what I would reach for when I actually want the deeper plan and the constitution layer. The 4 planning steps — specify, plan, tasks, analyze — produce a bigger spec and a more thoroughly implemented codebase. And analyze does more useful polish work than OpenSpec's verify did in this run. The cost of that depth is real, roughly double in the wall clock for the same delivered PRD, around 81% more on the Claude bill. If the project is non-trivial and the change history matters, that cost is a fair trade. The spectrum I want to leave you with looks like this. On the lean end is OpenSpec, where the loops are fast and the artifacts stay light. On the heavy end is GSD-with-auto-mode, which adds autonomous chaining on top of deep planning, so the framework manages the workflow end-to-end. SpecKit sits between them. Same depth of planning as GSD, no autonomous chaining. That is the most useful way I have found to describe it. SpecKit is what GSD would look like without auto mode. A wishlist note while I am here. Both of these would be much stronger with an auto mode, especially SpecKit. Typing each command in the per epic loop manually was the most tiring part of the run. By the 3rd or 4th epic, I caught myself missing GSD's autonomous chaining. OpenSpec would benefit too. The proposed apply archive loop is already fast enough that chaining a few of those autonomously would make it the default choice for nearly everything I work on. Bonus points if either framework could spin up a sub-agent per phase instead of running everything in the main context. OpenSpec actually ships a first-party shortcut that helps a bit. OPSX propose rolls the planning ceremony into a single command, so you go from I want to make a change to all planning artifacts in one prompt. SpecKit has TinySpec doing the same idea on its side, but TinySpec is a third-party community extension. Neither shortcut chains the full loop to the end. That is the gap I want filled next. Both frameworks have evolved since I last looked. First by what you optimized for, not by who won. There is not a clean winner today. Some of you keep leaving these comments that I should blink more. I read you. The thing is that I haven't really recorded myself on camera before starting this channel, and believe me, delivering like a 20-minute script is not an easy thing to do. The on-camera part I'm working on, and the deliveries will keep getting more natural. Thank you very much for watching, and I will see you in the next one.